Hi everybody, today we're going to talk about similar polygons. So first we're going to talk about what a polygon actually is. So a polygon is just a figure that has at least 3 straight sides and angles. So these are all just examples of polygons. So one way we can classify polygons is by calling them similar. So in real life, similar means that there are some things that that two things have in common, but they're not exactly the same. In math, we consider two polygons to be similar only if they meet these two specific requirements. 1, all corresponding angles must be congruent. And remember, corresponding just means they're in the same relative location within the polygon. And congruent, of course, means equal. The second requirement is that all side lengths are proportional. So we're actually going to set up different ratios for the sides, for the corresponding sides, and check that the proportions are equal. And all similar polygons that have they have what's called a scale factor. So it's essentially the ratio of the corresponding sides that's simplified. And this scale factor just tells you the difference in size between the two similar polygons. So first we're going to decide if these two triangles are similar, and if so, we're going to state the scale factor. So the first thing that we need to check is that the corresponding angles are congruent. So you could see here we have a 90 and a 90, and then we have a 40 and a 40, so those are congruent. And that would make our last angle 50, because all of the angles should add up to 180 degrees. So since we have 3 congruent corresponding angles, we can put a check there. Now the next thing that we need to check is that the sides are proportional. So I'm going to create a ratio for each of the corresponding sides. Now you can see that this second triangle is kind of twisted, so you have to make sure you match up the sides correctly. So let's first figure out which side would go with the side length 4. So I see that 4 is between the 90-degree angle and the 40-degree angle. So if I look at the other triangle, I see that 8 is between the 90 and 40. So those are the corresponding sides. So I can set up a ratio 4 to 8. Now, if I simplify that, that's a 1-to-2 ratio. Now, we do need to check that all of the sides follow this same proportion. So let's try 3. The 3 is between the 90 and the 50, so that will go with the 6. So 3 to 6, which is also simplified to a 1-to-2 ratio. And then the last two, 5, will go with 10. You can also tell because they are both across from the 90-degree angle. So 5 to 10 ratio, which is also a 1-to-2 ratio. So since all 3 have the same ratio when it's simplified, we can say that these two triangles are similar. And the scale factor is just a 1-to-2. There we go. All right, so let's try this one. This one says, are the two rectangles similar? So this word is actually really important because rectangles have all 90-degree angles, and that is going to be important when we're checking because we do have to check for corresponding congruent angles. So we can tell since all of the angles are corresponding, we know that they're all 90, we know that the corresponding angles are congruent. So we can do a check mark there. And now we have to see if the sides are proportional. So we're going to set up our ratios. So I can see that side length 2 will go with 3. So that's a 2-to-3 ratio. And I can see that 4 will go with 7. And that's a 4-to-7 ratio. Now neither of those fractions can be simplified, and they are not equal to each other. So because the side lengths are not proportional, we would say that these two rectangles are not similar. So therefore, they don't have a scale factor. All right, so at this point, go ahead and pause the video and give this problem a try. All right, so let's check together. So I can see that all 3 angles are congruent. So that meets our first requirement. And now I'm going to set up the ratios. So I can see that 4 is going to go, it's between the 90 and the 50, so it's going to go with 6. So we say 4 to 6, which is a 2 to 3 ratio. The 8 is going to go with the 12 because they are both across from the 90. And this would also simplify to a 2 to 3 ratio if we divide both the numerator and denominator by 4. And that means that our last pair will be the 6 to 9, which also is a 2 to 3 ratio. So since all three of the ratios are the same, we would say that they are similar and that the scale factor is 2 to 3. Okay. The last thing we're going to do is we're going to actually use the fact that two polynomials are similar to help us find missing sides. So this first says, assuming that these two polygons are similar, first we're going to write a similarity statement. So that just means that when we're describing the two shapes that are similar, we do need to make sure that the angles match. So let's say I call this first polygon DCBA. Now we use this little squiggle. This squiggle represents, oops, I made it disappear. This squiggle represents the symbol for is similar to. Now we just have to make sure to match the corresponding angles. So since I said angle D first, I have to say angle Z first because that's the corresponding angle. C goes with Y, B goes with X, and A goes with W. So the order that you list them in matters. So this is our similarity statement. And now we need to solve for X and Y. So here, the first thing I'm going to look for is a space or a ratio where I know both of the sides. So I can see that these two sides, 18 and 4, I know both of them, neither of them have an X or Y. So that's a ratio that we can use to help us find missing sides. So it's an 18 to 4 ratio. Now I can set up another ratio. We can say X to 3. So X over 3. And then we can solve this by cross multiplying. So we say 18 times 3 equals 4 times X. And then we will say 54 equals 4X. And then we can divide both sides by 4. And here we get this, which we do need to simplify. So here we can say X equals 27 over 2. So there's our X value. Now we can do the same to solve for Y. This was our baseline ratio because we know both of those sides. And then we also know that Y plus 2 will correspond with 5. So we say Y plus 2, and I'm going to group that to 5. And now I can cross multiply. So we can say 18 times 5 equals 4 times Y plus 2. So 90 equals 4Y plus 8. So you can see here that you have to remember to distribute. So I'm going to subtract 8 from both sides. 82 equals 4Y. So Y equals 82 over 4, which we need to simplify. So I'm going to divide the numerator and denominator by 2. And we get Y equals 41 over 2. Alright, this is the last problem. Go ahead and pause the video, write a similarity statement, and then solve for X. Okay, let's check your work here. So it will be triangle ABC is similar to triangle DEF. If your order was different, that's okay as long as the corresponding parts match. And then we can set up the ratio 2 over 3 equals 1.5 over X. And if we cross multiply and solve, we get X equals 2.5. And don't be nervous to divide with decimals. It's just normal long division. You can just add a 0 at the end if you need. All right, that is all for today. Thank you for watching.